Welcome to a new episode of the podcast. Vox Agent is made by AI for business executives that work with AI. Today, we're diving deep into a profound shift that's reshaping how software gets built, driven by the incredible advancements in AI. We're talking about something called vibe coding. Our mission for this deep dive is to unpack exactly what vibe coding is, how it works, the tangible benefits it offers enterprises, the crucial challenges to consider, and where it's headed next. To give you a mental image, maybe think about building something complex, like a skyscraper. For decades, software development was kind of like meticulously placing every single brick by hand, right? Following a blueprint line by line.
Yeah, very precise, very manual.
Exactly. Vibe coding, though, it's more like describing your architectural vision, the feel, the function, the vibe to this highly skilled, almost instant assistant. And this assistant lays all the bricks for you precisely, rapidly. You, the human architect, you're still in charge, focusing on the grand design, making sure the quality's there.
Right, the oversight is key.
But the repetitive manual labor is largely handled. It's a fundamental reimagining of the whole build process, really. So, vibe coding, it sounds almost artistic, doesn't it? Where did this intriguing term actually come from? And what does it fundamentally change about how we approach building software?
It's a great question, and the term itself really captures the core idea. Vibe coding was coined by AI expert Andrej Karpathy. At its heart, it describes this new paradigm where human programmers collaborate directly with AI, specifically large language models or LLMs.
Okay, the big AI models we hear so much about, like behind ChatGPT and others.
Exactly, those. And the key shift, the really big change, is that the developer's role transforms quite dramatically. They move from being, a low-level coder writing every single line of syntax to becoming more of a high-level coordinator. So instead of typing out all the code, they communicate the desired vibe or the intent of the software using high-level natural language prompts and guidance.
So less writing a detailed instruction manual, more like providing creative direction.
Precisely. Think of it that way.
That's a fascinating reframe. Can you give us a concrete example, like what does that vibe or intent communication actually look like day to day?
Absolutely. Let's say you need a new feature, maybe something that analyzes sales data. Instead of the developer writing a complex algorithm from scratch, they might just prompt the AI, saying something like, okay, I need a Python function that reads a CSV file of sales data, calculates the total sales per region, and then identifies the top 3 performing regions.
Just like that, in plain English.
Pretty much. The AI then attempts to generate that exact working code.
Yeah.
But, and this is crucial, the human developer stays in control. They review it, they refine it, maybe iterate with more prompts if it's not quite right.
Oh, okay.
It's very much a human-centric approach. The developer is like the conductor or maybe an editor, guiding the AI, verifying the output, making sure the vibe is actually correct.
So it really does sound like we're moving up another big level of abstraction in how software gets made. We went from wiring circuits to assembly, then high-level languages like Python or Java, then frameworks.
Abstracting away the lower-level details each time.
Yeah, and now with vibe coding, it feels like we're abstracting the very act of coding itself, moving it to a more conceptual level. It's about expressing the intent, not just the syntax.
Okay, here's where it gets really interesting for me. We're talking about these AI assistants being embedded right in the workflow. How do these tools actually integrate into a developer's day-to-day? What are the core capabilities making this shift possible?
Right, the integration is key. The core of vibe coding is how the AI assistant becomes just, part of the development environment. It's typically embedded directly into the developer's code editor, the IDE, like VS Code or JetBrains tools.
Okay.
It often shows up as maybe an interactive chat window, or it gives you inline code suggestions as you type. Some newer tools like Windsurf editor are even being designed as agentic IDEs, where the AI isn't just a helper, it's an active collaborator.
An agentic IDE? Wow, so what can these things do? Well, they really excel at natural language code generation and editing. You give these high-level instructions, and the AI can produce entire functions, modules, even scaffold out whole projects.
Like a whole project structure.
Yeah, potentially. Or, say you need a new API endpoint. You could tell it, create a new REST API endpoint for customer data. Make sure it includes validation and unit tests. A REST API endpoint, just for context, is basically a specific web address an application uses to send or receive data.
Got it.
And the AI generates the controller code, the data model, the tests automatically. It can also modify existing code across lots of files. Imagine saying, okay, rename the customer class to client everywhere in the project.
Which could be dozens of files.
Easily. And the AI handles that refactor, keeping everything consistent. You can even tell it things like, vectorize this loop for performance, and it'll try to optimize the code for you.
That's pretty powerful stuff, generating refactoring. What about taking it further, like acting on its own to fix things?
That's where this agentic behavior comes in, and it's a really key capability moving forward. Some advanced vibe coding systems can actually carry out sequences of actions to reach a goal without needing a prompt for every single step.
Okay, like what?
So, for example, in some beta tools like GitHub Copilot X or Cursor, the AI might write some code, then run the tests, see a failure, adjust the code based on the error, and repeat that whole cycle until the tests pass.
All on its own?
All
Wow.
autonomously, yeah. The AI acts like an autopilot for certain tasks. It's essentially driving itself towards a working solution. And beyond just writing code, they offer powerful testing and debugging help. AI can generate unit tests for your code automatically, which helps improve test coverage without a lot of extra manual work.
That alone sounds like a huge time saver.
It is, and some more sophisticated agents can actually run the tests, read the error messages if they fail, modify the code to fix the bugs, and then rerun the test to check the fix. It dramatically speeds up that whole debug cycle, the find, fix, verify loop, which often eats up a lot of developer time. And thinking about teams, vibe coding can really enhance collaboration and knowledge sharing. Because the AI is trained on so much code,
Right, vast amounts.
it acts like a real-time mentor. It can suggest idiomatic ways to do things, or maybe flag existing functions in your own large code base that you didn't even know were there.
So it helps avoid reinventing the wheel.
Exactly. And it helps democratize expertise. Junior developers can tackle more complex tasks sooner, maybe even work across different tech stacks like a Python dev, getting help writing some Go code.
That's interesting. Reduces bottlenecks, maybe?
Potentially, yes. And critically for enterprises, these tools usually integrate with version control systems like Git, so you can track the changes the AI makes. Many platforms also provide audit logs for compliance.
Okay, that's important. Showing what the AI did and why.
Essential for trust, accountability, and any regulatory needs.
It really sounds like it completely changes the rhythm of the workflow, almost like it keeps developers in that productive flow state longer.
That's a good way to put it. The idea is the AI handles the tedious context switching, the mechanical parts of coding. You can move seamlessly between giving natural language instructions and then maybe editing the AI's generated code.
Right.
It frees you up to focus on the higher-level strategy, the creative problem-solving, while the AI handles more of the road implementation details.
Okay, so let's connect this back. What does all this actually mean for you, listening maybe as a business executive or someone focused on driving efficiency? What are the big, tangible wins companies are seeing from adopting this vibe coding approach?
Yeah, let's talk bottom line. If we connect this to the bigger picture, the impact is really quite tangible, hitting core business goals directly. The most immediate takeaway, I think, for any executive is just accelerated productivity and time to market.
Faster development.
Much faster. And this isn't just like a small improvement. It's often a step change. Studies, like the ones GitHub did for Copilot, show developers completing tasks significantly faster. Figures like up to 55% faster coding are often cited.
55%. Wow.
Yeah, and maybe a 26% increase in the number of tasks completed, with no reported loss in quality. That translates directly into getting features out the door faster, quicker value realization. It fundamentally changes your competitive speed. Another critical insight is improved code quality and consistency. The AI can help reduce errors. It can automate test generation, essentially giving you pretty comprehensive test cases for free in some scenarios.
Right. More testing means fewer bugs later.
Exactly. And it helps enforce consistent coding standards across large teams, which leads to cleaner code, fewer defects down the line. Thomson Reuters, for instance, they observed a 39% improvement in code quality in their internal studies.
39%. That's a massive reduction in technical debt and future maintenance costs.
It really is.
That's huge. What about the human element, though? How does it impact the teams themselves?
That leads nicely into the third major benefit.
Yeah.
Enhanced collaboration and knowledge sharing. As we touched on, the AI kind of democratizes expertise. Junior developers can become productive faster, contribute more meaningfully sooner.
Makes sense. Speeds up onboarding, too, I imagine.
Dramatically.
Right.
We hear anecdotes of onboarding time shrinking from weeks down to hours in some cases. And it helps ensure consistency, even across distributed teams. It's like having this universal, always available assistant everyone can tap into. And finally, you roll all these benefits together, and it translates into direct cost savings and efficiency gains. You're simply doing more with the same or maybe even fewer resources. You might reduce outsourcing costs, lower maintenance costs because of fewer bugs.
And happier developers, maybe. Better attention.
That's a big factor, too. Higher developer satisfaction. GitHub reported 68% of Copilot users felt more satisfied. That contributes to better talent retention. And retaining good engineers is a massive indirect cost saving for any enterprise.
Okay, these sound like powerful benefits, but are these just theoretical? Or are there real-world examples of major companies actually doing this and seeing these results?
Oh, absolutely. These aren't just theories anymore. Take Morgan Stanley, for example. They actually developed their own in-house AI tool called devgen.ai, specifically to help modernize their legacy code.
Legacy code. That's always a challenge.
A huge one. They use GPT models to translate something like 9 million lines of old code, like COBOL, Fortran, languages many younger devs don't know, into plain English descriptions.
Just understanding the old code is half the battle.
Exactly. And that process alone saved them an estimated 280,000 developer hours. Astounding. Their CEO even mentioned this could save individual employees up to 15 hours per week. They built it in-house, importantly, for security and customization, keeping humans in the loop throughout.
Okay, that's a big financial institution. What about other sectors?
Look at Thomson Reuters, the big information services company. They've taken a broad, multi-model, multi-vendor approach to adopting AI across their engineering teams. Their internal studies backed up those GitHub numbers, developers coding 55% faster, seeing that 39% improvement in code quality.
Wow, consistent results.
Yeah, and 68% reporting a positive experience. One of their execs even said, and I'm quoting roughly here, any company that's serious about developing technology needs to be using agentic AI software development tools. That's a pretty strong statement from a major enterprise.
It certainly is. Any others?
Yeah, consider Abnormal Security. They're a cybersecurity firm. A really significant portion of their engineers, maybe 50% to 75% of around 350 engineers, are actively using agentic AI tools like Cursor.
In cybersecurity, speed and accuracy are critical.
Absolutely. And interestingly, they've even used generative AI tools like v0.dev for UI design, for the user interface. They noted it actually took the place of Figma in a lot of user workflows.
Replacing design tools.
In some workflows, yeah. It dramatically shortens that loop from design idea to implemented interface. That lets them iterate on their product incredibly quickly, which is vital for staying competitive in a fast-moving field like cybersecurity.
What's really striking here is, like you said, these aren't just small experiments anymore. These are major, established companies weaving AI into their core development processes. They're seeing real competitive advantages. It's not just hype, it's delivering tangible ROI for the business right now. Okay, this all sounds incredibly transformative, maybe, almost too good to be true sometimes. While the benefits are really clear, it surely can't be entirely without its challenges, can it? What are the key hurdles enterprises need to watch out for when adopting vibe coding?
You're absolutely right to ask about the flip side. While the potential is immense, there are definitely critical challenges to navigate carefully. On the purely technical side, code correctness and reliability are still major concerns.
The AI isn't perfect.
No, not by a long shot sometimes. AI-generated code isn't always correct. One report even noted something like, AI-generated code sees 41% more bugs if it's not properly overseen by a human developer.
41% more bugs.
Oh, okay. That's significant.
Yeah, it can introduce subtle logical errors, maybe suboptimal solutions, or sometimes code that just plain doesn't compile. If developers just blindly accept suggestions without critical review, quality can definitely take a hit. There's also sometimes an overhead of iteration. Getting truly production-ready code from an AI might require multiple rounds of prompting and refining.
Back and forth.
Exactly. And in some cases, especially for simpler tasks, the back and forth could actually make it slower than just coding it manually, particularly if the developer isn't yet skilled at writing effective prompts.
Right. Prompt engineering is a skill in itself.
It really is. And the AI might lack a comprehensive architectural awareness. It might not fully grasp the bigger picture of the entire software system, potentially introducing designs that conflict with the overall architecture unless you explicitly guide it very carefully. So definitely not a magic bullet. What about security and intellectual property? Those are always huge concerns for big companies.
Huge areas, yes. There are significant security, privacy, and intellectual property, IP, risks to manage. There's the risk of data leakage, developers inadvertently feeding sensitive customer data or internal trade secrets into AI prompts to give it context.
Yeah, that's scary.
Definitely. And on the IP front, there's the concern that the AI might inadvertently reproduce code snippets that are very similar to code it was trained on. This raises questions about copyrighted material or maybe restrictive open source licenses like the GPL, the general public license.
Which could force you to open source your own proprietary code if you're not careful.
Potentially, yes. Solutions are emerging, like using data filters or running models on-premise, but the legal landscape around AI-generated code ownership is still, evolving. Then you have the organizational and cultural resistance. The whole narrative around AI replacing programmers can cause real anxiety and job security fears among development teams.
Understandably so.
Yeah, so it's crucial for leadership to emphasize augmentation, not replacement, helping people do more, not getting rid of them. There can also be a lack of trust in the AI's output, or sometimes the opposite problem, over-reliance and complacency, where developers just merge AI code without proper review.
Which could lead back to those quality issues.
Exactly. And that complacency could even lead to skill atrophy over time if developers stop practicing fundamental coding and debugging skills because the AI handles the routine stuff. And finally, there are practical integration challenges. How do you adapt existing processes like code review? Reviewing 50 AI-generated changes is very different from reviewing 5 human-written changes. New strategies are needed. Adapting CI/CD pipelines, that's continuous integration, continuous delivery, the automated build and deploy process and issue tracking also needs thought. So it really raises the question, how do enterprises mitigate these risks effectively? The key seems to be maintaining strong human oversight, establishing really rigorous governance policies, using secure or on-premise AI models to keep sensitive data safe, and crucially, investing heavily in training developers.
Training them how to use these tools responsibly.
Exactly. Building both trust and competence in using these powerful new tools.
Okay, given all of this, the incredible potential on one hand and these very real challenges on the other, what does the next, say, 3 to 5 years look like? Where is vibe coding and software development heading in the enterprise? What should we expect?
Well, we're definitely looking at a period of exciting and probably very rapid evolution. Expect a clear progression from where we are now, which is mostly assisted coding. The human is firmly in the driver's seat towards much greater autonomy, often called agentic coding.
More autonomous AI agents.
Yes. Future AI agents might be able to take quite high-level specifications or goals and handle much more of the implementation end-to-end. Humans would still be involved, but more for setting the goals, defining the constraints, and giving final approval.
Like OpenAI's rumored agentic software engineer.
Exactly. That's the kind of direction things seem to be heading. An AI that could potentially plan and execute a significant software project from just a high-level prompt. It's like moving from, say, advanced driver assistance in cars towards something like level 4 autonomy, but for coding. We'll also likely see deeper integration of AI throughout the entire DevOps pipeline. Remember, DevOps combines development and operations. So imagine AI not just writing code, but also monitoring your build pipelines, automatically making adjustments if a build fails.
Or even fixing bugs found in production.
Potentially, yes. Assisting with production operations, maybe generating patches for bugs detected in real time. The AI becomes more like an embedded team member, active at every stage of the software lifecycle.
So it's definitely not just about writing code anymore, but the whole process.
The whole lifecycle, exactly. And it probably won't just be text in, text out either. Multimodal and multi-agent systems are definitely on the horizon.
Multimodal meaning?
Meaning future systems could accept different kinds of inputs, maybe diagrams, maybe voice commands, maybe even rough GUI designs sketched out. And multi-agent means you might have specialized AI agents collaborating.
Like different AI roles.
Yeah, imagine an AI QA engineer working alongside an AI software engineer. One writes the code, the other writes the tests and tries to find bugs in it. You can get this robust, automated check and balance system. Enhanced context and memory will also be a huge game changer. As LLMs get larger context windows and better long-term memory, they'll be able to effectively know the entire code base, the project history, the established architectural patterns.
So they understand the bigger picture better.
Much better. Which allows for far more holistic code generation and smarter architectural refactoring, because the AI understands system-wide conventions and dependencies at a much deeper level than today. And all this naturally leads towards metaprogramming and even higher levels of abstraction. Developers will increasingly focus on writing specifications, defining constraints, describing the what's and the why.
And the AI handles the how.
Increasingly, yes. The AI handles the translation into executable code. This means developers will spend even more time on the really valuable human parts. understanding the business logic, designing the user experience, making core architectural decisions, domain design, while the AI handles the implementation details. Your human judgment becomes the crucial navigation system for these ever more powerful AI copilots.
So wrapping up, vibe coding is clearly more than just a buzzword. It's a genuine paradigm shift, fundamentally amplifying human potential in software creation. It seems to be about doing more with less effort, doing it faster, and potentially doing it better. For enterprises, embracing this thoughtfully, responsibly, it really isn't just an option anymore, is it? It's fast becoming a competitive imperative. So as this powerful collaboration between humans and AI continues to reshape how software gets built, maybe the question to leave you with is, what kind of innovative software will you be able to build or enable your teams to build when the AI is handling more and more of the heavy lifting? Thank you for joining the podcast, and see you soon.